Our guest today is a renowned professor from University of California, John Bolander, right?
Yes,
it's nice
correct.
to meet you.
Nice to meet you.
And namely, you are from the Department of Civil and Environmental Engineering. Is that right?
That's correct.
Perfect. Thanks a lot once again for your time. You're here at our Faculty of Civil Engineering at the Brno University of Technology, and you had a lecture here,
Yes,
right?
I did.
How was it?
I think it went well. It was appropriate length. It was a nice time for presenting material and then questions.
Okay, and how long was it? How long was the lecture?
The lecture went about 40 minutes, and then
Okay.
we had 20 minutes for questions.
Okay, interesting. One thing was that, so you came here for the lecture, right? And what else brought you here from the United States?
It's mainly to do research.
Okay.
And my work is on construction materials and their applications in structures.
Right.
And we're particularly interested in how things break.
Right.
And so they break in various ways. And it could be mechanical loading due to vehicle traffic, cars on a bridge, for example. Or it could be wind or earthquakes. But it's also the actions of the environment. Solar heating, wetting and drying processes. The environment is also aging our structures. So that's another form of how they break, and then that breaking feeds into further deterioration. So concrete's like our body, and then if you get a cut, bad things can go in. When our structures break, they open up and they let the environment in to attack the inside of the structure. That's in simple terms. And so we're interested in how things break, how to prevent their breakage, and manage our existing civil infrastructure.
Very interesting. So you came here to participate on a research with our colleagues here at the faculty, right? You do also work at ADMAS Center or here at the faculty? We have an ADMAS Research Center here in Brno.
No, I'm here at this...
At the faculty?
Yes.
Right, okay. You've been here for 4 weeks?
Nearly 3 weeks.
Nearly 3 weeks. Have you had a time to visit Brno?
Yes, I have.
And how do you like it?
I like it very much.
Yeah?
Yes.
You live in the city of Davis, is that right? In California. How would you compare those cities with Brno?
Davis is a smaller town. It's nice in that it's a university town. So we're centered on college life. We have many students coming from around the world. So it's a nice environment. This is more of a city where you see working people, and it's a larger city.
Yeah. It's also Brno is called a student city in Czech Republic terms as well, because we have here, I think it takes there's almost I think 70,000 students.
That's a lot.
For 400,000 residents.
Yeah.
So it's a student city as well. Right. So if you would compare the faculty, how would you compare the faculty with your faculty in the University of California?
Well, coming back to what I know in my own research, I'm using what are called deterministic methods, where I make computer programs, and every time I push the button, the same results come out. So it works in that sense. My colleagues here are very good at stochastic processes and modeling uncertainty, probability. They're very strong in that. And so that's one of the ways that we come together. What I'm doing and what they're doing are complementary. So it's a nice research exchange. So for example, when the modeling that's being done here are accounting for uncertainty. And all of the things that we do involve some form of uncertainty.
Sure.
So when I compare our faculty, I think there's real strengths here in this modeling of uncertain processes. And this is going to be more and more important as we go into the future, managing risk, and that extends into our civil infrastructure.
Right. Very, very interesting. I'm delighted to hear that. There is I would say, a synergy with those universities. Just one thing came on my mind right now. How did you connect from California with Brno? It's pretty far apart, those two places.
I used to go to many conferences, and in recent years I've toned it down, but I was going to international conferences, and I meet scholars from around the world, and Janem Eliášem and then some other colleagues here, they really stood out. And so we made some connections at these conferences.
Yeah, that's perfect. One thing that really struck me when I was doing the research for this interview was that your department is called Civil and Environmental Engineering. So your department is focused a lot on the environmental aspects of civil engineering. Do I get it right, or?
That's a fair way to characterize it. We have 5 focus areas. So I'm in structural engineering, structural mechanics. We also have geomechanics. So those are the hard side. Then we have environmental engineering, water resources engineering, and then transportation engineering. And so transportation's kind of in the middle, but we have the soft side, which is air quality, water quality, managing environmental systems, and then we have the hard side, which is structural engineering, structural mechanics, and geomechanics. And so these are 5 focus areas, and we have fuzzy boundaries so that we like to collaborate. I can collaborate with people on the environmental side, they can collaborate with me.
That's perfect. I liked it because for example, here the environmental concerns are more and more important for all of us, but we lack the Department of Environmental Civil Engineering as by the name. But we all take it in account, the environmental side, but that just struck my eyes.
May I add that that's common in the U.S.
Right.
So it's when you see it at our institution, it's not an anomaly, but most programs in the U.S. are civil and environmental. It's common. Right.
So as you've touched before, you are interested in the material engineering, right?
Yes.
And I read that with emphasis on high performance materials. Is that right? So you've touched on it, but can you once more describe what is your research based on and what are the goals of your research?
We have gained an appreciation for how concrete behaves over decades and decades of field experience and testing in the laboratory. But many of these structures are large and they're subjected to complicated loading histories, as I mentioned. So it's not just the vehicle traffic, but it could be freezing and thawing cycles and wetting and drying cycles that over time damage accumulates. So we're developing computational models to complement knowledge bases that come from just looking at what's happening in the field and doing lab tests. And lab tests are expensive, and it's really hard to replicate what's happening in the lab. I mean, in the real environment in the lab. But when we build a computational model, we have I call it numerical experimentation. It's a type of experiment. And it differs in that we have complete control in the 3D sense, what's happening in the 3D sense, but also on all the boundary conditions. How it's interacting with the environment. So we can replicate or try to replicate what's happening in the real life inside the computer.
Yeah, right.
And then we can take traditional materials and then play games with them and say, how can we improve their performance? And one of the ways is by adding fibers, short distributed fibers within concrete. Concrete is traditionally reinforced with bars.
Right.
If you look at before they pour the concrete, you see bars. And increasingly we're understanding that you can, rather than having one big bar, you can distribute the reinforcement in the form of discrete fibers, many small fibers. And there's advantages to doing that, particularly in restricting cracking. So that's a direction of high performance, is to, it's very difficult to prevent cracking, but what's important is to make the cracks small. If it's going to crack, keep the crack small and not connected through the depth of the structure. Right. Prevent large cracks from happening. And that's one type of high performance criteria that we're aiming for.
Very interesting.
I know it's a lot of detail.
I don't think so. I think our students are very clever and will understand it fully, I'm sure. Just one on a personal note, how did you get into such a topic, into such a research? How does one get into such a research?
Well, keeping your eyes open. I did work for many years in the field. I was working on construction sites. I was doing some construction contracting, cost estimating. I had that practical side. And then when I went back to graduate school, I could see what we know and then what we could do if we went to computer modeling. So I think having one foot in the practical side helped me. To see the advantages of what I'm doing now. Yeah.
I think that's a common way of when you see it in the, as we call it, real life, right? And then you come back to the university and try to make it better, right? Just one other thing that really struck me was when I was looking at the courses that you teach. And you've touched on that. I saw that you teach a C programming for civil engineering. Is that right? I was fascinated by that because I think it can bring a lot of possibilities to civil engineering if more students are educated in programming. But I wanted to ask you about especially for C programming, C language programming. Where do you see the possibilities of use of this language in civil engineering?
It's interesting you bring this up because as faculty, we always argue about what's the most appropriate programming language. So the idea to teach C programming was not met with uniform enthusiasm. We have many faculties want the students to use MATLAB. Do you know what the program? Many of the faculty believe that MATLAB, it's a more higher level programming language. The students can get to the application sooner. They're not looking at the nuts and bolts of the program. And there's other faculty that believe that learning the skills of C, then you can always move to MATLAB later. If you learn MATLAB, it's difficult to go to C. So let's teach C. So we had a lot of discussions about what to teach. And so let me just say, I think it was successful. The students enjoyed it. We had some good projects in the course. But the other faculty, it wasn't complete buy-in.
Right.
It wasn't, and that's always going to be the case. When you have faculty, everybody has their pet language. And they want that language to be, and so, but it was very enjoyable, and the students, I believe, benefit from that.
Right, and you use these C programming or the MATLAB for modelings of the real life, as I would say it?
We're using, me and my students, we're using a variety of languages, and I've used C, C++, mostly for the pre- and post-processing of analysis. So you have an analysis engine, and I'm using a dinosaur. I'm using Fortran, modern Fortran. But then we wrap it. We have a wrapper around it, and that's MATLAB's C, C++. That does the builds the model, and then once you analyze the model, then you can interpret the results with these other programs. So we're using a lot of different programs, in different languages.
Very interesting. then just another course, and I just wanted to ask you that you teach a course on earthquake loads on structures, which really intrigued me. Although we don't have any massive earthquakes here, I think it was like 4 on the scale, like at level 4 here somewhere in Czech Republic, but nothing compared to US, right? But I just wanted to ask you, where do you see the you focus on those materials, right, in the earthquake context?
Yeah,
is that right?
That's correct, but it's mostly structural dynamics, and with special loading, earthquake type loading. So we don't get into the issues in the undergraduate course about the cracking of the material and how the structure might fall down. It's really about how the structure, when it's shaked, how it responds without these damage mechanisms. It's an entry-level course into the subject area. So you might have a course on structural dynamics here, and there would be many similarities. I think the main difference is that we have this ground shaking, and how we handle ground shaking and the special nature of the ground shaking. So I'd say it's 75% a course on structural dynamics. Then this 25% is very special to earthquake ground motions.
Interesting. Perfect.
And it's an entry level for the undergraduates. And then we have another course at the graduate level that goes further in that direction, but we don't really quite get into how things break and fall down.
Yeah. I see. That's perfect. Just one last thing before we wrap up this interview. Would you have any or even more recommendations for our students at this time? As you know your topic, what should they study? What should they be focused on in civil engineering, in your opinion? What should they look around for? Any recommendations for our students?
I think this issue of bringing in the uncertain nature of what we're doing, and the specialty is here, it exists here at this institute, that being able to, I'll put it into the context of bridge deck cracking. I have a project with the transportation agency, and they say, will the bridge deck crack? And they want an answer, yes it will, or no it won't. And the answer is really in between. And so many of the things that are being studied here, there's not a clear answer. When you do a homework problem, students like it when they get the answer. But when you move into practice, many things don't have a definite answer because of these various forms of uncertainty. So I think it's a difficult subject when you start, but it's very rewarding to go in that direction. I wish I had more of it when I was a student.
Professor Bolander, it was a pleasure to meet you. Thanks for your time, and I hope you will enjoy the rest of your stay here in Brno.
Thank you so much, and I'd really want to acknowledge my host, main host here, Janem Eliášem, and then all the faculty members. They've made me feel at home. I've had a really good time here.